Hey, my name is Lucky Owafia, and this is my Lab 1 charge tapes for Physics 2212. The purpose of this lab is to explore the electrostatic interactions between two charged pieces of tape and observe their effects on each other while being suspended in the air. Our goal will be to measure and model how electric forces can balance the gravitational forces to cause one piece of tape to seemingly float above another. Results indicated that a charge of about 4.6 e to the negative 8 and the number of electrons lost to have been about 5.8 times 10 to the negative 6 electrons. So there are a few fundamental principles that this lab will rely on. Firstly, Newton's second law is a very important one, and that law states that the acceleration of an object is equal to the force divided by its mass. Secondly is Coulomb's law, and that is just the expression that the force is equal to the K constant times the two charges involved and the distance between them squared. Lastly would be the gravitational force, which is given by F equals G times the mass of one object times the mass of the other over the distance squared. However, for the purposes of this lab, M times G will be used, where G is equal to 9.8 meters per second squared. There are a few key assumptions for this lab as well. One such assumption is that each tape will behave as a point charge. Additionally, that there is no air resistance or friction present. Lastly, that the charges on the tapes are small, however still significant enough to observe a meaningful effect. Now we're going to go over some of the experimental setup for this lab. In the top right corner, you can see the general layout that we'll conduct in the lab, which will also be present live in the next slide. To prepare the strips of tape, 2 strips of Scotch tape, about 20 centimeters each, will be ripped apart to induce a charge. The system will be a charged piece of tape, and the surroundings will be the uncharged tape and earth. The mass of the tape was calculated or estimated to be about 0.2 grams, and its dimensions were about 0.2 meters by 0.02 meters. The floating distance that we observed would be about 9.95 centimeters above the lower tape. Additionally, for the further calculations in this lab, an atom will be given an area of about 1 times 10 to the negative 20th meters. One of the goals of this experiment was to calculate the amount of excess electrons present. Here I will walk you through those steps. Starting with 1, the force of gravity on object or the piece of tape B, or the higher piece of tape, was given by mass times gravity, and that was equal to about 1.96 e to the negative third. Once it floats, the force of gravity was equated to the force of electricity given by the first piece of tape. This can be equated to each other to find the charge, as seen in step 3, which was about 4.64 e to the negative 8 coulombs. The area of the tape was given by the product of the side lengths of the piece of tape. A number of atoms was then given by the area of the tape divided by the area of an atom, and that was about 5 times e to the 16th. For the excess number of electrons, that was given by the charge deduced earlier divided by 1.6 e to the negative 19th, and that yielded 2.9 e to the 11th. For the fraction of atoms with excess charge, that was given by the solution to the previous step divided by the number of atoms. That yielded 5.804 times 10 to the negative 6 power, or otherwise about 5, or more accurately, about 6 in 1 million atoms in the piece of tape had acquired some type of charge. So for an overview of the code, here we can see the output of my code and the upper tape and lower tape, as well as the required charge to hold up the two objects in sort of stasis in the air. Key steps in the code included a definition of constants, a computation of the actual charge, which was the output, a periodic updating of the charge, and a visualization of the spherical objects as well as the text. All of these pieces of codes can be found in the 4 images below. So our observations matched the model, and we got a charge of about 4.66 e to the negative 8th, and this matched roughly with the charge that we calculated of about 4.4 e to the negative 8th. Any sources of error may have been due to an uneven charging of the tape, and handling might have also caused unwanted discharge of charge. If the electrons were positive or the protons negative, the results would in fact be the same, and the only difference would be a swapping in the signs throughout some of the calculations. We want to minimize the handling of the tapes because touching by a neutral object can cause discharge to happen, which would reduce the charge and decrease the effect that we see in the floating later in the experiment. So again, we find that the estimated charge was roughly about 4.4 e to the negative 8, and that the electric force does in fact produce a strong enough force to balance out the gravitational force for these two pieces of tape. Our model and predictions are consistent with the observed data. Thank you.